Welcome to our in-depth exploration of energy transitions, where we will compare three leading power sources: solar, wind, and nuclear energy. Each of these options presents unique advantages and challenges, shaping the future of global energy landscapes. In this video, we'll dive into key aspects such as energy output consistency, land use, costs, and public perception, while also examining their environmental impacts. Join us as we uncover how these energy technologies can contribute to a sustainable and efficient energy future. 1. Solar power. Harnessing the sun's infinite energy. Solar power is a remarkable leap in harnessing renewable energy. It captures sunlight through photovoltaic (PV) panels or concentrated solar power (CSP) systems, transforming it into electricity. This method is advantageous because sunlight is abundant and inexhaustible, making it a sustainable energy source for the long term. However, the process of manufacturing solar panels does require significant resource extraction and energy use, which can have environmental implications. Despite this, once installed, solar panels have a minimal environmental footprint, making them a popular choice for those looking to reduce their carbon emissions. Solar energy's potential is vast, especially in sunny regions, where its deployment can significantly reduce dependency on fossil fuels. 2. Wind power. Capturing nature's breath. Wind power is another key player in the renewable energy sector, utilizing turbines to convert wind movement into electricity. This energy source is entirely dependent on the availability of wind, making it renewable and sustainable. However, the effectiveness of wind power can vary greatly depending on geographic location, as it requires consistent winds to operate efficiently. While wind energy has a low environmental impact, it can pose challenges for local wildlife, including birds and bats. Additionally, wind farms often occupy large land areas, but the land between turbines can still be used for agriculture or other purposes, making it a versatile choice for energy production. 3. Nuclear power. A powerful, non-renewable option. Nuclear power is unique in that it uses uranium or other radioactive materials to generate heat through fission, which is then converted into electricity. It is not a renewable resource, but it can provide a high energy output over an extended period, making it a reliable option for meeting base load energy demands. One of the significant advantages of nuclear energy is its ability to produce electricity without emitting greenhouse gases during operation. However, the mining of uranium, the management of radioactive waste, and the potential for accidents like Fukushima present substantial environmental and safety challenges. Despite these issues, nuclear power remains an integral part of the global energy mix due to its high energy density and consistent output. 4. Energy output consistency. Bridging the gap. The consistency of energy output varies significantly between solar, wind, and nuclear power. Solar power is highly dependent on the time of day and weather conditions, leading to fluctuations in energy production. To maintain a steady output, energy storage systems, such as batteries, are often employed. Similarly, wind power is variable due to changes in wind speed, and wind farms are most effective in regions with reliable wind patterns. In contrast, nuclear power provides a continuous energy supply, operating around the clock without significant fluctuations, except during maintenance or planned outages. This consistency makes nuclear energy a vital component of the energy grid, capable of supporting other intermittent renewable sources. 5. Land use. Space and efficiency. The land requirements for each energy source are distinct. Solar power needs large areas for utility-scale solar farms, although rooftop installations can mitigate land use concerns. Wind turbines also require significant space to function effectively, but the land can still be utilized for other activities, such as agriculture. On the other hand, nuclear power plants occupy relatively compact areas, but they require additional land for safe storage and disposal of radioactive waste. This aspect of land use is a critical consideration in the planning and development of energy infrastructure, influencing the choice of energy sources based on available space and regional priorities. 6. Installation and construction time. Speed and complexity. The time required for installation and construction is a crucial factor in the deployment of energy projects. Solar power installations can be completed relatively quickly, ranging from weeks to months, depending on the project's scale. Wind farms also have a swift construction timeline, but larger projects may take several years due to permitting and construction processes. In contrast, nuclear power plants require extensive time for construction, often spanning 5 to 10 years or more. This lengthy timeline is due to the complexity of the infrastructure, rigorous safety standards, and regulatory processes involved. The time factor influences not only the initial investment but also the speed at which energy needs can be met. 7. Cost. Economic considerations. Cost is a significant consideration when comparing energy sources. The price of solar panels has fallen dramatically in recent years, making solar power one of the most cost-effective renewable energy options, particularly for decentralized systems. Wind power is generally cost-effective as well, though costs can vary based on location and project size, with offshore wind being more expensive than onshore installations. Nuclear energy, however, involves high upfront capital costs and long construction times. Despite this, nuclear power can provide low-cost electricity over decades if the plants are well maintained and efficiently operated. These economic factors play a critical role in determining the feasibility and attractiveness of each energy source for different regions and applications. 8. Energy density. Efficiency in energy production. Energy density, or the amount of energy produced per unit of fuel, varies widely among solar, wind, and nuclear power. Solar energy has a low energy density, requiring large areas to generate significant electricity. Wind energy is more energy dense than solar but still necessitates numerous turbines to produce substantial power. In stark contrast, nuclear power boasts a very high energy density, with a small amount of fuel capable of producing large amounts of energy over time. This high energy density is a key reason why nuclear power remains a crucial part of the energy landscape, especially in regions with limited space for renewable installations. 9. Storage requirements. Addressing intermittency. Energy storage is an essential component of solar and wind power due to their intermittent nature. Solar power often relies on battery storage systems to provide electricity during off-peak times or at night. Wind power also requires storage solutions or backup generation, although its variability can sometimes be offset by regional grid integration. Nuclear power, on the other hand, does not require storage in the same way, as it can produce a continuous power supply. The need for storage solutions highlights the importance of developing efficient energy storage technologies to complement renewable sources and ensure a stable and reliable energy supply. 10. Public perception. Acceptance and concern. Public perception plays a significant role in the adoption and development of energy sources. Solar power is generally well received due to its clean, quiet, and non-intrusive nature. Wind power, while also considered clean, faces opposition in some regions due to concerns about noise, visual impact, and bird mortality. Nuclear power often encounters public resistance due to safety concerns, the potential for catastrophic accidents, and the long-term challenges of radioactive waste disposal. These perceptions can influence policy decisions, funding, and the overall direction of energy development, underscoring the need for transparent communication and engagement with communities. 11. Carbon footprint. Environmental responsibility. The carbon footprint of each energy source is a critical consideration in the global push for sustainability. Solar power has a very low carbon footprint after installation, with most emissions arising from manufacturing and transportation. Similarly, wind power's carbon footprint is primarily linked to the production and installation of turbines. Nuclear power also maintains a low carbon footprint during operation, with emissions mainly stemming from uranium mining, plant construction, and waste management. These attributes make solar, wind, and nuclear power attractive options for reducing carbon emissions and combating climate change, each offering unique benefits and challenges in the quest for a sustainable energy future.